Hey guys, it's a little throwback to Miss Manley for you. Hope you're doing great. Hey, we're on 6-4 here, which is going to be on pages whatever in the workbook. I'm sure you guys are smart enough. You'll figure it out. We're going to talk about, so we know our three transformations: turns, flips, slides. If they're fancy names too. Today we're going to work on a combination of two of them together. Okay, hey, I've got one shape here in quadrant 2, and it moves to quadrant 1. How can I get it there with a couple of these, like with a rotation and then a translation or something like that, okay?
Page 316, 317, everybody.
Did you hear that? 316 and 317 is where we're going to be, okay? So we call this multiple motions, right? Multiple motions, we're going to use 2 or more of our motions to get us where we need to be. This will all make sense here. Example 1 is terrible. Did you look at example 1, Mr. Noel?
Example 1, not a good one.
We're going to go right to example 2, folks.
Wow,
Right?
he's just going right over it.
Right to example 2. Example 1 is terrible because they're rotating. No, it doesn't make any sense. All right, look, everything we get is always going to be on a graph.
Translate quadrilateral
MNPQ,
7 units left, and then reflect it across the line x equals -3.
Okay, so this is one of the things that we're going to have to do. Multiple motions. Do them in order. Okay, sometimes you can still end up in the same spot if you do them out of order. Sometimes you won't, though. So we're just going to do them in order. So the first thing I want to do is this translation, right? We're going to go 7 left. Super easy. 7 left. Brings it over here, right? Then we're going to reflect it over x equals -3. Wherever that is, I don't know, okay? Hopefully they're going to do that for us here. Okay. Glide reflection is a fancy name for it. We don't really care, folks. We're just going to translate it first, and they did that. So again, every point, literally every vertex, I should say, just moves 7 left. Bam. Here we go. M prime, N prime, P prime, Q prime. There's our new quadrilateral. What was the second motion? It was that reflect over x equals -3. Again, that's going to be a line right here. We've never done a reflection like this, so you might want to pay attention. Okay? Check this out. Okay, here's that line of reflection I was just referring to. Why does this line of reflection look different than all the other ones we've seen?
It goes through the shape.
Yeah, we've never seen one like this. I'm actually kind of curious what's going to happen. So, yeah, usually it's been like over here, and then the shape is reflected over here. But if you think about it, I've got 2 points that are on one side of the line of reflection, and then I got 2 points over here on the opposite side. I'm kind of curious, Mr. Noel. I don't know what's going to happen. I'm going to hit next here. We're just going to see. Whoa!
Wow.
Interesting. Do you guys see that?
Yeah,
Okay.
If not,
Yeah, maybe. Okay, there we go. So look, these look weird, and they kind of are, but it all makes sense, right? Let's just look at point N. N prime. Ooh, we got 2 prime marks here. Okay, so there's the first thing. We can talk about that. So if we see, or if we're reflecting and translating, we're doing multiple motions. Each motion gets another set of prime marks, right? So it made sense we called this N prime. Then when I reflect N prime, remember, it can't be N prime anymore. So we just add a second. We call this double prime. Woohoo! Okay? But take a look. It's only 1 unit away from the line of reflection. Where do things reflect? On the opposite side of that line of reflection. Bloop. That's why it ends up over here, 1 unit away, and we call it N double prime. Okay? M, same thing, 1, 2 units away from the line of reflection. It reflects on the other side. It actually ends up over here where this original P prime was. No big deal. Okay? So this all makes sense, right? We're just reflecting over that line on the opposite side, so it makes sense that the points would kind of cross. Okay? We had a homework question like this. You know, we did okay on it. Okay, anyway, Mr. Noel, you unzoom that for me so I can please? Okay? So guys, there you go. Double prime, yep. Example 2, showing us some things we haven't seen before. 2 motions, do them in order. When you have 2 different figures, now we call the first one prime, the second one double prime. Okay, example 3. I think we have an additional example for the... Ooh, finally a good video here. All right, this one's going to be good.
What is a sequence of transformations that maps triangle ABC onto triangle A double prime, B double prime, C double prime.
I don't know.
To begin solving this problem, compare the two triangles. Do you think that a sequence made only of translations could map one triangle onto the other?
Ooh. I'm gonna say no. Again, guys, map is just a fancy word for move. So if we just move that like look, I would say these triangles are pointing like kind of in opposite directions. So no, I don't think just translations alone is good enough.
The two triangles are mirror images of each other. So a sequence made only of translations will not map one triangle onto the other. Instead, a reflection must be included.
Yep.
The green triangle is the reflection of the orange triangle across the y-axis.
Okay.
You can make this triangle an intermediate image in the mapping sequence. To begin, translate triangle ABC 8 units to the right, and then 6 units down. This maps it to the intermediate image, triangle A prime, B prime, C prime.
Yep.
Then reflect the triangle across the y-axis to map it onto triangle A double prime, B double prime, C double prime. Can you think of another sequence of transformations to map the blue triangle onto the orange triangle?
Okay. So guys, this is the other thing we're gonna have to do. So the easy part, they'll give us 2 moves and we do it. Or maybe 3, I don't know. All right, the other kind of problem is gonna look like this. Hey, here's your pre-image, here's your image, figure out how this goes here. I don't like the way they did it. Did you like the way they did it, Mr. Knoll?
No.
Okay, here's what I would do, right? And it says, hey, can you think of another sequence? Well, the sequence I want to look at is all about orientation first. So if I look at my pre-image, right, I'm going clockwise around it. A, B, C. Okay? Start at A. Look down here at our image. Again, I'm going to go clockwise around it. I go A, C, B. That tells me my orientation changed, and that tells me, hey, like lights and sirens should go off. We have to do a reflection. Reflection is the only one that will change my orientation back.
Has to.
That I need to do. So if I know I have to reflect, I want to do that right now. Okay, this is why I don't like the way they did it. They slid it all over the place and then they reflected. We're not going to do that, right? I would like to reflect this right off the bat, okay? You reflect however you want. I think it's a great idea, right? Some of us have better spatial awareness than others, right? I can see, hey, you know what? I kind of want B to be facing like B prime down here. So if I reflect it over the y-axis and it reflects over here, that would be great. Then I think I could probably slide it down and then slide it left. So if I were doing this problem, that's exactly what I would do. I would reflect over the y, okay? Or if you wanted to be fancy and not move it as much, you know, you could reflect it over x equals -3 or -2 or -1 or any of those, okay? But look, I think for most of us, reflections over the x or y axis are easy. So that's where I would start. I would reflect over the y, then I would translate down and translate left, okay? And we would end up in that same spot as the red figure down here. Let's see what they say, though.
Let's see.
Many other sequences will map the blue triangle to the orange triangle. One sequence is a reflection across the line x equals -4,
Yep.
and then a translation 6
Straight
units down.
That works too.
Many other sequences can be constructed.
Yep.
Many.
They say. Many. And that's true, right? And this is why this is kind of so hard for a lot of us, because there's not just one right answer, okay? What is another sequence of transformations that maps ABC onto ABC double prime? So, okay. We can come up with one. You guys ready for one? Let's do that reflection first, though. Again, we know it's going to have to reflect. So let's reflect like we were talking about. Let's reflect over the y-axis first, okay? So we're going to do that. So here's B, 1, 2, 3 away. So B prime moves here. C is 6 away, so it'll stay 6 away over here. And A is what, 5 away, so A is going to be A prime. Okay. Okay, so now if you check your orientation, A, C, B, right? A, C, B, it's identical, A, C, B here. Now this tells me, hey, we're good. We don't reflect anymore. Otherwise, we're going to change it again. Now I just want to go down, and then I want to go left. So I'm going to look at B prime. I'm going to change colors here, right? So here's B prime. Here's B double prime. I need to go down 1, 2, 3, 4, 5, 6. Okay, so I need to go down 6. And then I need to go 1, 2, 3, 4, 5, 6, 7, 8 to the left, right? What was the first thing I did? We reflect over the y-axis, okay? So if we're going to describe a sequence, crew, this is what we got to do. You have to tell me specifically. You can't just say reflect and slide or translate. You can't do that. You have to be specific about what you want them to reflect over and how you want them to translate. So reflect over y-axis, I know what that means. Down 6, left 8. There's my translation. Again, very specific with the direction that we're going. Okay? So there's another sequence for us. Again, I didn't have to reflect over the y-axis. Like I said, I could have reflected over x equals -1 or -2. That would have been okay too. Okay? But if we have to do a reflection because our orientation is wrong, guys, I'm telling you right now, do that first. That will make our lives much, much, much easier. Okay, so with that, there's examples 2 and 3. 1, if you want to look at it on your own time, go right ahead. It's got a picture and the room thing, and it's just goofy. Yeah.
You want to do an additional one?
I don't know. Do we want to do an additional one? Sure. I mean, it's kind of the same thing, isn't it? Yeah, let's do this one. Bonus, guys.
Oh, I got you. Yeah, I hooked you.
Yeah, we're hooked in. Can you zoom in, Mr. Kroll, make that a little bit bigger for us?
Yep.
So, guys, I want you to pause the video right now and just, hey, check for orientation. If the orientation is the same, then we don't need to do a reflection. We can just rotate it or translate it. So, kind of take a guess as what you think it should be. Okay, hopefully you're back and you realize that, hey, orientation here on the pre-image, ABC. Orientation here on the image, ACB. So absolutely, we have to do a reflection, all right? Again, Mr. Fricke said do the reflection to start with, so that's what we're going to do. I'm going to be fancy. I'm just going to reflect it over that line right there. We don't even have to really know the name of it, because we kind of do, I guess, when we describe it. I take that back. So this just goes through -3, and it goes through our x-axis. So the first thing I'm going to do is reflect over the line x equals -3. Okay? When I do that, B prime stays in the same spot.
Good choice.
C is going to move 3 away. 1, 2, 3 away right here. Here is C prime. And A is 2 away, so A is going to be, A prime is going to be right there. Okay. Well, this actually worked out well for us, didn't it? All right, so my second move that I need to do, I think, is just going to be a translation, right? We just need to slide this down so that C prime moves all the way down here where C double prime is. So let's count how many spaces that is. 1, 2, 3, 4, 5, 6. So then we need to translate 6 units down. Okay? Do that, good to go. Okay? So this is the harder thing that we're going to do in 6-4. The easier one is when they just tell us, hey, can you please do these 2 moves? And then, bam, we're off and running, and that's what we've got to do. Okay? So anyway, we're going to head over and do some key concepts. I'll see you there shortly. Later.